Hey guys, welcome back to the third video. This time we're going to talk about the servos that we can use with the board. You should have at least one of these little servos that has the same type of plug-in that the accelerometer had. And then you should have as well something that looks kind of like this with the Arduino, the Grove shield, and then the accelerometer as well. So we're going to be attaching this to the board today and figure out how to make them interact with each other. So let's just quickly go over what a servo is and how it works. So a servo is short for servo motor, and it's not the same as a normal DC motor that you would see on like a RC car or something that just spins as rapidly as possible. What a servo motor offers is more precision and control. So how it works is it's got a potentiometer on board which measures voltage, and so with a different amount of voltage being applied to the servo, it can read that information and change the angle at which the motor is turned to get precise control. So if you wanted to turn a certain amount of degrees, you can do that with a servo motor, whereas with a regular motor you would struggle to do that because it doesn't have a precise control and there's no feedback for it to know where it is. So this picture here just shows a robot arm that I think it's a kit you can buy off of Amazon that has a bunch of different servos. I think it's got like 5 or 6 if I remember correctly, but it allows for servos are super important in robotics because basically every robot arm will use servo motors or some type of similar idea, and just because of the control that they allow and for the fluidity of movement and things like that. So just to give us some idea of what a servo is. To attach the servo motor to the board, it's very simple. You're just going to take the end with the plug, you're going to plug it into the board. Again, I'll do a close-up so that way you know which port exactly to plug it into, but you should just plug it directly into the board, and since I'm plugged in, it's moving. It might adjust itself if you have power to it because it's setting itself to a certain angle already. And that's it for attaching it to the board. The other thing that you are going to want to do is you're going to want to, it should come with a bunch of different like tips for the motor. This is the one I'm using. You can choose which one to use, but this one allows for like a flat surface, which is nice. So you're just going to take this and stick it on the end there, and we'll adjust it later, but that's all you gotta do for this. It comes with screws too, so you can screw it in and make sure it's on tight, but for now I wouldn't do that just because we're gonna need to adjust it a little bit later. So yep. Alright, so now since we have it connected to the board, let's look at the software one more time. So this is the same file that we did in the last video where we copied and pasted in. And let's go over some of the parts that we skipped over last time. So we make sure to include this servo library that allows us to interact with the servo a lot easier. Same idea as the accelerometer one as before. And here we're setting the servo as a servo variable, which is included in the library, and the pin that we're using, which if you plug it into the right one should be D4 on the board, so it's corresponding 4 here. So if we scroll down, last time we stopped around here just printing out the values. Now we're going to want to interact with the servo. So how the servo works is basically you're just inputting an angle into the servo and you're writing that angle into the servo, and then the servo responds. So you can input anywhere I think between 0 and 180 degrees, and the servo will respond with moving to that angle, which is nice, and it depends on the servo that you have too. Some of them have more and some of them have less of a degree of range. So with this servo write function, I encourage you to try different values and see what the servo ends up moving to, but we're going to move on to how we interact, how we have the accelerometer communicate with the servo. So that's what this code here does that we kind of skipped over. So if you remember from last time, we were talking about how the accelerometer has 0 for 2 values and then 1 for one of the values, and that's because the accelerometer is measuring acceleration, but it can't distinguish between the difference of acceleration of gravity and actual movement. So what we can do is we can use that fact that it is measuring gravity all the time, and using that we can measure what's pointing down and what angle the board is at relative to down, using a little bit more physics. So basically what we're doing is we're getting the value that it's reading in G's, which is 9.8 meters per second squared, times, or however many G's we have. So since we're getting the X value here, it's going to have 0 G's just standing on the board because it's perpendicular to the direction of gravity, where our Z value is 1 because it's parallel to the direction of gravity. Our X value is 0. And we're taking the inverse cosine of this, and the reason we're doing that is because what we're trying to get is the angle relative to down, and since we know down will have a G of 1, whatever G value we're reading is going to be in the range 0 to 1 somewhere, and if we take the inverse cosine of that, we can get that angle that we're at. So we take the inverse cosine and then we get that, but that's in radians and we want it in degrees, and so then we multiply it by 57.29 to convert to degrees, and that's the angle that we're getting. And then we're printing it out. So let's upload it. Make sure your board is connected. Mine is currently not connected, so I'll plug it in and then upload it to the board. And so once it's uploaded, you should have, if you have the accelerometer and the servo connected, you should be getting some movement by the servo. That's just due to noise from the accelerometer. So if we go back to Sketch and we go to, Tools, and then we go to Serial Monitor, now this time if we pause here, so stop auto scroll, this time we're looking at this. So we're looking at the X1 angle, and it's approximately 90 degrees. So 90 degrees is basically perpendicular to the table, which is what we want. So it's pointed straight up from the table, is what it's saying. And then if we turn auto scroll back on and we rotate to the left, to the right, you're going to see that the angle is changing. So you're going to see if you rotate to the left, you're getting a smaller angle, and if you're rotating to the right, you're getting a larger angle. And you'll also notice, if you have your servo connected at the moment, that the servo is moving itself too. And that's because, if we close this here, that's because we're taking this angle and we're writing it into the servo. So that way we're measuring from the accelerometer, using some of that data that it's reading, and then doing some computation on it, and then outputting it to the servo, so that way we can have the accelerometer control the servo. And this line of code here, it reverses the angle that it's moving at. So you'll notice if you turn your board to the left, the motor will turn to the right, and if you turn your board to the right, the motor will turn to the left. And that's just kind of what this project is about. It's just using the accelerometer to control the servo in different ways. So in this case, I made it the opposite, so that way if you attach the servo to the board, and now you can see like I said before, if you turn the board to the left, the motor's turning to the right, and vice versa as well. And so what this is doing is it's kind of creating a stabilizer, or like a steady platform. And it's not completely steady because of noise in the accelerometer, but if I turn it to the left, you'll notice that this stays completely flat. If I turn it to the right, it's always staying level with the ground or the table or whatever frame of reference you're using. And so this is just a simple introduction into what you can do with servos and accelerometers, and how cool it is you can measure something from the outside world and control something with a computer, with a very simple computer like this. So, and with more servos, you can measure different axes. So if you also rotate it like this or like this, you could change another servo. And I have some other ideas as well that I hope to keep informing you guys with, but I encourage you to experiment with these values. I mean, now you have a servo you can experiment with, you have an accelerometer you can experiment with, and the Arduino itself you can do many different things with. So there's many YouTube videos out there, and I just hope that this was helpful in getting you to know with what servos you can use, or what sensors you can use with the Arduino, and hopefully spark some ideas that you can apply yourself. So thanks for watching, and that'll conclude the tutorials with these sensors.